欢迎参加今天我们这项与 VisualARQ 共同举行的这次线上研讨会。这次我们邀请到的是VisualARQ 的产品经理，他是一名建筑师，同时呢，他有很强大的一个技术背景。那今天主要讲解的内容呢是VisualARQ 为 Rhino 和 Grasshopper 添加的主要的灵活的BIM功能，用于 Rhino 内部开发建筑项目生成2D 文档图纸，并为其他的 AEC 应用程序提供BIM模型。那此次演示呢，将针对的是中国观众，以中英文同时进行。那活动过程中如果有任何的问题，可以随时沟通。当然，结尾环节我们也会有一个问答的环节。所以如果有什么问题的话，可以在过程当中随时欢迎沟通。Okay, Francis, shall we start?
Okay. Let's go on. So, ni hao, everybody. Today we will see an overview of VisualARQ, and I'm going to show the main features of it for developing architectural projects in Rhino using the flexible BIM technology.
Okay. 好，今天我们重点的这个内容呢，其实是 VisualARQ 的它的一个主要功能的一个介绍。那这个目前如果说对于 VisualARQ 有了解的呢，我们可以进一步的去更加有一些深入的一些了解之后，然后可以有一些这个问题，我们可以来进行一个沟通。OK。
So what is VisualARQ for?
那什么是VisualARQ 呢？它是做什么的呢？
I'm gonna highlight the main 3 features, okay, of VisualARQ for developing projects. The first one is the option to produce BIM models in Rhino. That means developing projects that the geometry contains information, building information model.
那它的第一个主要功能就是它是基于 Rhino 平台上的一个BIM工具，它是用来进行一个建筑信息模型的一个非常实用且高效的一个工具。Okay.
The second point is the option to produce 2D drawings, 2D architectural drawings in Rhino. So VisualARQ provides tools to produce all these documentation drawings in Rhino of any architectural project.
好，那第二个主要的功能就是基于3D 模型生成或者是建立这个2D 的图纸。那我们在在这个 Rhino 当中去做好了这个3D 模型，或者是在其他的一些工具当中做好了这个模型之后，我们要出图纸。那这个VisualARQ呢，它是一个非常好的工具。
And finally, VisualARQ is used to exchange Rhino models with other software in the AEC industry through the IFC file format.
那第3个主要功能呢，就是可以输出 Rhino 这个模型以 IFC 的这个格式去进行输出。
So, based on these 3 topics, I'm going to highlight the VisualARQ's key features. Okay.
那VisualARQ 的主要功能呢，就是以下3个：3D 建模，还有输出2D 的文档，另外呢就是 IFC 文件的转换。
So, starting with the option to 3D model, VisualARQ provides a set of architectural objects. They are parametric. That means we can change their parameters to values, and we can easily edit them through control points, through the parameters. And also, these objects have like a different 3D and 2D representation.
好，那我们看到这一部分呢，它是智能建筑的一些构件。那这下面这一排其实是它这个 VisualARQ 里面它本身带有的一些构件、一些组件。那我们可以直接用这些组件，然后来去对 要所建的这个模型来进行一个设计和更改。
So the way to create these objects are different. On one hand, there are some native parameters. On the other hand, we can create these objects through Grasshopper definitions, providing unlimited possibilities of design and keeping these objects as parametric.
OK， 那我们同时呢也可以利用Grasshopper 来自定义样式对象，因为我们知道在在这个使用 Rhino 比较高阶的一个阶段的时候呢，Grasshopper 呢它是一个比较参数化的一个工具。那我们也可以使用 VisualARQ 来结合 Grasshopper 来自定义样式对象，这个呢就是比较偏参数化，但是非常实用的。
So I'm going to show very quickly how this works. We have a Grasshopper definition with a list of input values, and we create a new style using this Grasshopper file. We set the new style, we want to edit the parameters, and finally we've got an object in the model that is using this Grasshopper definition in the background. So we can insert it as any object, and later on we can edit the parameters that is actually being used from the Grasshopper definition. I'm gonna play the video again. Okay.
那其实就是在这个过程当中呢，我们看到就是在 Grasshopper 里面有很多的参数，这个参数呢我们可以通过这个滑块来去调动，比如说它的大小，以及它的这个方向，另外呢就是它的各个参数都是可以直接调整成自己想要的一个结果。对，在这个演示的过程当中，我们看右边它有很多的这个选项。
Okay. Actually, later on I will show some examples so you can understand better how it works.
OK， 后面我们还会有一些这个演示，可以更好的去了解。
So this integration of VisualARQ with Grasshopper allows you to, with one Grasshopper definition, have hundreds, thousands of objects with different dimensions.
在 VisualARQ 当中，我们可以自定义很多很多的样式，它是具有无限的可能的。比如说，像是这个图里面我们看到的这些样式，我们可以去自定义，把它变成不同的一些样式，在右侧这些所有的选项当中都可以去进行调整。
Well, in the website of Food for Rhino, you can download some of these objects, styles, that people share with the community.
OK， 那很多的组件，我们在这个 Food for Rhino 这个网站当中呢，有更多的样式可以直接下载。它里面这个网站里面呢，有很多的做了非常非常多的元件，并且呢，把这个楼层的概念放进去，我们可以就是查看所做的这个3D 图形，很多的一些它的构造。对，所以可以直接访问 Food for Rhino 这个网站，可以下载想要的组件。
One of the main features for developing projects in 3D is the level manager that lets you work at different elevations, show and hide levels, and align levels to specific views.
那第一个是楼层管理，那我们可以看到，在这个建筑当中，在这个3D 图里面，我们是可以看到顶层、第4层、第3层、第1层以及负1层，我们每个都可以分开来去看，这是一个非常大的一个亮点。对。
In a similar way, we've got a section manager that lets you have a list of sections and which can be jagged, okay, not just from straight lines, but from jagged lines. And well, we can show the model in section very quickly from this section manager.
那这个剖立面管理呢，就是在这个3D 模型当中，我们可以把它分成不同的区，可以查看它的 平面、立面、剖面图，可以按照自己想要的这个区域划分来去查看。
One of the main important features for producing 2D documentation is the option to print what you see directly to vector output. As you may know, when we are using raster shaded modes, we can only print what we see as a raster viewport, raster output. But if we would choose this hidden display mode, we can print what we see, a section, a 3D view, directly to vector output and get a beautiful, 2D drawing result.
那第二个功能就是矢量输出隐藏线，就是我们在去输出它的一个文档的时候呢，可以选择我们要输出的这个格式是什么样子，既可以选择它现有的这个格式，也可以选择隐藏隐藏以及其他的一些格式，或者是输出的这个线，各种方式都可以。
So this feature applied to architectural projects lets us print a plan view, a section view directly to vector output. We need to align a plan view in our page layout, or we can align a section view in our page layout and just switch to this hidden display mode and everything is ready to be printed to vector output.
对，那我们可以看到这个3D 模型呢，可以我们通过不同的这个剖面图去查看不同的这个位置，同时呢也可以直接打印出来。对，和刚才我们说到的这个内容是一样的，剖面图，然后加矢量输出隐藏线。对，这个出图 ，OK。
Another way to produce 2D drawings is by creating 2D sections and 2D plan views in the model space. And these views are linked with the 3D model. That means that we can update them at any time with the changes that have been done on the 3D model.
那我们看，那出的这个图呢，有平面图、剖立面图等等，我们也可以随时更改，对，也可以直接在这个立面图选择它的相对应的这个平面图，对。
All right. In relation to that, VisualARQ also adds section attributes for geometry, not only VisualARQ objects, but also to Rhino geometry. So when we see these objects in section, we can assign some hatch pattern, some line weight to the sectioned contour and get some nice, section attributes for the 2D documentation.
那剖立面属性，我们看某一个物体的这个剖面图的时候呢，那这个剖面图它的属性，我们可以去设置不同的颜色，对，以及其他的一些相关的一些属性，我们都可以去非常简单的去设置它。
Another feature for documentation is the table command that lets us show quantity takeoffs with all the information of VisualARQ objects. And we can list not only information of VisualARQ objects, but also Rhino geometry. We can list everything.
计量统计这个功能呢，就是我们可以直接统计所有你所选中的这个物件组件它的相对应的一些规格，然后直接呢把它列出来。
And of course, we can export those tables to Excel file.
对，我们同时呢也可以把这相关的数据统计导出成报告，比如说这个 Excel 表格。
Okay, now talking about IFC, since VisualARQ has architectural objects, that means that when we export a model with these objects to IFC, other programs like ArchiCAD, Revit, Solibri will identify these objects as the architectural objects they are.
那其实 BIM 的软件呢有很多种，比如说Solibri、Revit、ArchiCAD，这些软件呢，其实都是我们可以通过 IFC 的文件格式去与 Rhino 进行交互的。那 VisualARQ 呢，也可以生成 IFC 软件，与所有的这些软件进行一个交互。对。
And depending on how these objects have been created, through IFC, the other programs will identify them as native objects, as if we had created them directly in ArchiCAD or in Revit.
那在 VisualARQ 当中，然后生成的这个 IFC 的文件是可以在其他所有的这个 BIM 软件当中去进行一个打开和读取。
But any geometry, any Rhino geometry can be tagged with a specific IFC information. For example, we can take this freeform polysurface and tell it that this is a slab. So when we export that to IFC, other programs will recognize this as a slab.
那任何对象都可以赋予 IFC 类型与 IFC 的属性，比如说这个组件，那我们可以把它导出创建为 IFC 的类型。那在右边的这个框里，我们可以去设置它的属性，比如说它的类型，对，名称，然后描述等等等等。
Well, in addition to this IFC type, the object type, we can add custom information to any geometry. So we talk about BIM, we talk about geometry with information. So we can fit into any object information such as the manufacturer, the cost, the material, status, any data that we want to add to any object.
那在输入 IFC 的文件过程当中，我们去设置属性，可以添加客户所希望添加的所有的一些参数化的一些内容，包括材料以及成本制造商还有它的状态，这些我们都可以在这个所输出的文档当中去显示出来的。
And of course, this information will be stored in IFC files as IFC properties. So other programs will read this information as well.
对，那所做的这些更改也会在 VisualARQ 的这个 IFC file 文件里面保存和显示。
And why we talk about flexible BIM? So, which is the concept of VisualARQ. Usually, BIM means restrictions in the creativity, right? So, VisualARQ tries to be the opposite of that. VisualARQ tries to be flexible in working with BIM, but with any flexibility to work with freeform shapes, organic shapes, and having any custom design, but still working with BIM.
那为什么我们今天的主题其实是灵活的 BIM 呢？因为其实像是建模以及建筑类的建模，它其实是在这个行业当中有一定的这个具体规定和要求呢。但是我们同时呢，又是必须非常创新，而且呢，在满足客户自定义的这个要求的前提下，我们去做的这个灵活的一些这个 BIM 的一些功能，对，所以今天我们的重点还是这一部分。
And one of the main reasons of this flexibility is the integration with Grasshopper. So VisualARQ integrates in two different ways with Grasshopper. On one way, we have already seen that you can create VisualARQ objects from Grasshopper definitions. In the other way, all the VisualARQ objects are available inside Grasshopper as components to integrate them with all the Grasshopper ecosystem.
那首先第一个就是我们在用到 Grasshopper 的时候呢，VisualARQ 也可以与 Grasshopper 整合。第一个方面是Grasshopper 的里面的所有的样式都可以在 VisualARQ 当中使用。另外呢，就是Grasshopper 还有VisualARQ 里面的组件，它是可以共同互相使用的。
Well, with this process, I explain a little bit the different kinds of components. There are components to create objects, components to create object styles, and then there are components to deconstruct objects so we can get the information of visual objects, or we can deconstruct the styles to obtain the information of these object styles.
Okay. 好，左边这一边呢是创建样式，那右边呢是结构这个样式。那创建样式我们可以看到这个滑块，它前面是有这个对应的这个功能的名称，另外我们可以左右滑动，这样子去调整它的一个样式。
So, well, with this integration, we can create parametric structures, parametric designs using columns or slabs as this parametric tower that we see here. Amy?
OK, sorry. 就是我们可以通过这个参数化的工具 Grasshopper 呢，在VisualARQ 里面构建对象，对它进行一个解构修改，以及调整参数，可以有不同的所有的这些样式，既可以在右边的这个框里进行一个左右的一个滑动，同时呢也可以直接在这个物件本身上面进行一个调整。刚才 Francis 已经演示过了，对，在这里我们可以也进行一个调整，对。
Another option that is useful, this integration is, for example, if we want to assign names to all these objects, we can automate this process. And just with a few components, we can assign names to all these columns in a few seconds.
那在这个组件当中呢，我们可以看到纵向有很多柱体。那我们在对它进行一个标注的时候，可以进行一个自动化，在几秒钟之内就可以对所有的这个组件物体进行一个标注，它的型号是什么样子，对，不用再去手动去标注柱体，或者是进行一个编号。
Another way to take advantage of this integration is by using the Grasshopper player to produce parametric designs with VisualARQ. So in this case, we reference a Grasshopper definition. We just need to follow the steps in the command line and produce this parametric structure from this file.
那这个 Grasshopper Player GH Player 这个功能呢，就是我们非常它是一个新功能，它是有一个编程档案在的，在 Rhino 里面打开之后呢，可以很快速的进行一些这个程序化的一个编辑，包括产生楼层啊，或者是编辑这个相对应的这个参数啊，都可以有一个写好的一个命令，对，然后我们来去做这个是比较又快，然后又好编辑又好查看。
And the advantage of this integration is that you don't need to know Grasshopper at this point. You can just run the Grasshopper script, but you don't need to know how it works to produce this design.
OK, 好，目前来说就是可以了解一下这个Grasshopper， 但是具体的如果说想要具体怎么操作的话，然后目前来说我们可以之后再进行一个演示。对。
Also, these Grasshopper components let us communicate VisualARQ with Revit through the Rhino Inside technology. As you may know, this technology lets you run Rhino and all the plugins like VisualARQ inside Revit. So anything that we produce in Rhino will be transferred automatically through Grasshopper into Revit. So what we'll get here in Revit are true Revit objects.
那其实在这个里面呢 ，VisualARQ Inside 它可以打包到Revit 里面。我们在建模的时候呢，可以看到两边的这个进程呢是同步的。对，这个呢 VisualARQ Inside 可以进行一个连接，这样子呢去更加简化了我们的建模。
In a similar way, also we can connect VisualARQ and ArchiCAD with this Grasshopper plugin of ArchiCAD that lets us connect the VisualARQ objects into these components and regenerate everything in ArchiCAD.
那同时 VisualARQ and ArchiCAD 同时也可以进行一个关联。我们在 VisualARQ 里面所进行的操作，其实是可以同步到ArchiCAD 里面。
Well, now I'm going to show some projects, some user projects based on these three different, methodology. And this is a basilica in Croatia where VisualARQ was used to produce everything, the 3D model and also the 2D drawings.
接下来我们会看一些这个示例，按照我们刚才所进行的3项这个内容的一个演示。我们接下来看一些案例吧。
These two other examples are architects that use VisualARQ for producing 3D models quickly and shooting renders, for visualization.
那下面这2张图片呢，其实就是用 VisualARQ 来去建模，并且去渲染出来。
And this is a student project from China, by the way, that won a student contest that we organized early this year. And he produced this beautiful project with VisualARQ objects, but also produced all the 2D drawings with VisualARQ.
那下面的这个项目是中国的一个学生在2022年的BIM设计大赛上获奖的一个作品。我们可以看到不同的这个平面图，然后以及它的这个设计出来的这个成品图都可以看到。那这个就是用 VisualARQ 展示。
Actually, he also played a video using Lumion. So VisualARQ can also connect with these render engines like Lumion, Enscape, and so there are some plugins that connect Rhino with these platforms, and of course, all the VisualARQ geometry can get materials, and you can produce beautiful results by combining these tools.
这个视频是这位中国学生自己所做的一个视频，他在设计这个作品的时候呢，使用了 VisualARQ 去进行设计，同时呢用了 Lumion 这个渲染软件。那 VisualARQ 与 Lumion、Enscape 还有其他的一些设计软件都可以集成，然后去进行一个后期的渲染。
All right, so this video is available on YouTube. And this is another example where the users used VisualARQ for historical BIM, HBIM. They scanned a building, real building in 3D. They brought the point cloud into Rhino, and with VisualARQ objects, they recreated that project.
那从3D 扫描至3D 模型，我们可以使用VisualARQ 在对一个3D 对一个物体进行一个3D 扫描，那它可以直接生成一个3D 模型。
Well, this is a project that doesn't have any single VisualARQ object, but VisualARQ was used to produce the 2D drawings. So it's not really necessary to work with visual objects to produce the sections or elevations or plan views afterwards.
那我们可以直接使用这个 Rhino 的模型，可以快速的出2D 的图形。对，我们可以看到这几个图都是出图之后呢，带有相关的参数。
And also, these tools, the documentation tools, can be used for product design, like this example, which has nothing to do with architecture.
从这个 Rhino 模型快速出来的这个2D 图呢，也可以直接用于编辑并且去生成自己的这个模型。
And finally, VisualARQ is used to enrich IFC files. So thanks to VisualARQ, we can import IFC files into Rhino, work with the geometry, work with the data on the geometry, and finally export the model back to IFC to deliver the IFC or BIM model.
那 IFC 模型还可以与其他的 AEC 程序交互数据，这个包括这个我们看到这个 IFC 的这个格式，
Well, these are some values of VisualARQ. It's available on Rhino 5, 6, and 7. That is evaluation version of 90 days. Licenses are permanent, no maintenance fees or anything like that. They are forever. And there are also educational licenses with the same policy as Rhino educational licenses. So you can use them for commercial purposes, and they don't expire either, even if you finish the studies. And well, we provide free technical support. UI is available in Chinese, and we based our development on users' feedback. Okay, so we are always very open to receive feedback and develop VisualARQ accordingly.
那下面的这几项呢，其实是VisualARQ 的一些价值，包括它适用于 Rhino 5、6、7版本，同时呢有90天的测试期限，长期授权，没有维护费。那教育版呢和商业版的功能是一样的。另外一个就是它的技术支持是免费的，同时还有中文版的这个界面。另外一个是基于用户反馈的一个开发模式，而且还提供API。那价格呢如果有相关的问题，可以直接咨询我们的销售。
And well, there are plenty of learning material available on our website. So just explore by yourself all the content. There are video tutorials, there are webinars, there are small tutorials, and we offer courses and custom training eventually as well.
OK， 那在使用 VisualARQ 的过程当中呢，有很多的这个教学资源，我们可以在上面的这个网站里面可以找到，包括视频教学，然后或者是参加网络研讨会。在这个过程当中有问题呢，也可以随时的去跟Francisco 去沟通。那同时也会有一些中文的一些内容，我们可以看到它有这个中文的一些界面的。但是大部分的这个视频应该是英文的。
All right, so this is, well, the website, our contact support. Of course, you can also contact Cogito software for any questions. And well, now I'm going to show with a live demo some of these features we have seen in this presentation.
那关于产品，如果说还有什么问题，可以随时和我们去联系。接下来的一部分呢，是一个现场的演示。Francisco 会演示一些关于具体的一些 VisualARQ 它的操作，我们可以现在去观看一下。
Okay, so let's go for the demo. We can see here some architectural project, small house, and well, we can find here the architectural objects. Okay, so from these icons, we will be able to create new objects, also edit the styles that are what define the features of VisualARQ objects. Here we can find some edit tools for performing Boolean operations between objects, similar to those that we've got here for Rhino. Okay, and well, some documentation tools for creating tables. Okay, for creating spaces, areas.
Sorry, I think well, I can't see your screen now. It's still in the PowerPoint.
Oh, sorry. I'm gonna make a new share. Thank you. Can you see it now?
Yeah.
All right. So thank you for letting me know. So it was introducing the VisualARQ toolbar, the main tools. We've got here these architectural objects that well, we can use to produce any 3D model. Doing right click on these icons, we will open the styles editor for each object type. We can find here some edit tools like these ones that are for subtracting objects or adding objects in a similar way that we've got these Rhino Boolean commands. Okay, for filleting, also splitting objects, flipping the direction of objects. Here we can find the documentation tools for creating areas, list of well, schedule tables, tags, sections. Okay, 2D drawings, this plan view or section view 2D drawings, and these are for opening the level manager on one hand and the section manager on the other hand, which are these features that let us navigate through the project very, very easily. We've got some additional tools here to update objects, to create custom profiles that we can use on beams, columns, openings. We can also select objects by type, select all the walls, for example, at once. And well, we will basically work with VisualARQ through these panels. And for example, here we have the level manager that allows us to work at different elevations and have different levels on these construction planes. Okay, we can quickly switch from, for example, the ground floor. Anything I draw now will be created on that level. If I select the terrace floor, now everything will be created on that terrace level. Okay, from the front or right views, we've got these reference lines that tell us which is the well, the current level and the elevation of each one. With this level manager, we can also show and hide levels. For example, we can put the construction plane on the ground floor and hide the roof. So we'll see the inside of this terrace floor. Or we can hide the terrace floor and see the inside of the first floor. Actually, if we do double click on one level, we will automatically put the construction plane on that level and hide the levels above. So if I do double click on the ground floor, I automatically hide all the levels above and put the construction plane here. Also, levels have this cut plane, which moves this clipping plane at that distance, okay, that is relative to the level's elevation. And when we activate this cut plane from the top view, let's do it now for the ground floor, then we see the VisualARQ objects in a 2D graphical representation. So the feeling is that we are working in 2D, but actually these are 3D objects. If we rotate the view, you will see that this 2D representation disappears. We can put this back to plan view from this icon over here. So again, just doing double click on one floor or another, we will be able to navigate very easily through the project. Also here, there is some small icon that lets us see the projection of other levels on the current level. And this is very useful to get, you know, an idea of where the other objects in upper levels are located. Okay, and we can snap on these objects, although this is like hidden geometry, locked in geometry. Okay. All right. So In a similar way, we've got the section manager. So we have already some section lines here. Okay, we've got one over here, another over there. So if we activate the section C, we'll see the project in section from this section line. Of course, we can move this to see a different position of the section line. And we can also switch from one section view to another from these icons here. Okay. We can create new sections using this icon or this one. So we select a style, and we can have a jogged section like that. We can just do this as if we were drawing a polyline. We do right click to finish the command. Then we define the viewer position. Let's say this is S4. And now we will be able to see the project in section from this jogged section line. We can also move these control points and have totally different, jogged section. All right. So this is very useful to navigate through the project, to visualize the project, but also for documentation, for producing documentation. For example, if I am now in the right viewport and I want to display the section C in that view, we can select it, and with this button, we can align it to that viewport. So we can work now directly on this view, okay? And it's like if we were working directly on the section view. And if we set this view to the page layout, for example, here I have the page layout with two viewports. We can say inside that view that we want to show section C. And inside that other view, we want to see section 4, S4. So, or the section B, for example. And since I'm using this hidden display mode, okay, in this viewport, I will be able to print that directly to vector output, as we were seeing in the presentation. Okay, so I can use a vector output, define the output DPI, and produce 2D drawings directly from the 3D model. All right, and this could apply for not just parallel plan views, but also from any 3D view. As long as I'm using this hidden display mode inside it, I will be able to print directly to vector output. All right. I'm gonna cancel by now. Okay, let's see how to work a little bit with visual objects. Of course, we won't see them all today, but you have the feeling how easy it is. For example, I'm gonna work on the ground floor. I'm gonna insert some walls. First, I need to select some style. The styles define, for example, the number of layers of each wall, the thickness of each layer, and well, some basic information. For example, the attributes, the material, and stuff like that. We can assign here the style, also some height, also some alignment. Okay, and start drawing walls as if we were drawing polylines. As simple as that. Okay, we can just close this and get this kind of room. Then we can insert doors or windows. Okay, and again, we get a list of styles like this hinged double. Here you can see a preview of that. Well, all these styles are styles defined with the basic options for doors, which with level of detail is not really complex. It's very simple, actually. But we'll see an example of how to create a more developed, more detailed door using this Grasshopper styles option. So here I can define also the size. Okay, there are some preset dimensions, but also I can change that by any other dimension. And once this is here, I can also have different copies of this door, which will detect the nearest wall and will perform the opening inside these walls. And I can take one of them and, for example, change the style. okay, with a hinge double, or maybe a hinge simple glass. And also change the dimensions in this case, or also the how is it displayed in 3D. So I want to show it open. Okay, and from the top viewport, what we get is the 2D representation of these doors, and as well this wall with all the connections and hatches accordingly. Actually, walls can be created from curves. Imagine that we want to change this wall and have it make it from a curve. So we can draw a curve like this. Maybe we can snap on this endpoint. And now we have the option to create walls from curves under the wall command. We need to select one style. We select one curve, and the wall is created here. Okay. Sometimes we may need to adjust this in order to doesn't have wrong collisions with the neighbor walls. Another option we can do is to change an existing wall, and we can edit its features from this panel, and we can also change the path. So we click on this icon, and now we select that curve. In that case, all the doors will keep attached to the wall and will snap into them. Of course, these walls are not following, so we can just extend them using these extension arrows. So we can extend them until they hit the wall. So basically, walls have different control points that lets us, edit their positions. We have these extension arrows, but we have also some points at the bottom to stretch them at any direction. Okay. And in the case of walls created from curves, the control points are the same. Sorry, I was editing the original curve, but the control points are the same as the original curve. Okay. Okay, let's create a new style for walls. So you see how is the process, because VisualARQ comes with a template with different styles, a library of object styles, but you can create your own style. If we do right click here, we will open the styles editor walls, and here we can see the list of existing styles. For example, we have the generic 200 millimeters. We can come here and change different information. Okay. For example, if we expand this, we will be able to edit the features of the one specific layer. So we can change, for example, the thickness of that layer, all right? Or the function if it's a core layer, normal layer. So core layers will tend to intersect core layers of other walls. So you can play with these parameters to create your own style. You can add layers to existing styles. Here we can add some more layer, or we can create a new wall style from scratch using this wizard. So let's call this new, and just follow the steps of this wizard to say, okay, I want 3-layer wall style, and define the name and the thickness of each layer. Okay, for example, I want this to be just 12 centimeters. Maybe the layer will be 4. Imagine that's like a isolation layer, and this one will be 12 too. So totally we have a 28 centimeters layer. We finish, and we've got this new layer here. We can see this preview in 2D or in 3D. And if we expand that, we'll be able to edit the information of these 3 layers just by selecting each one of them. For example, here we can change the normal attributes, but also the section attributes, or the material, or in which layer we want to put this object, this layer. We can assign, for example, a solid hatch pattern for the first and the 3rd layer. Okay. All right. We say okay, and now, for example, we can change these walls. And I'm gonna also change, I can change them all. Go to the wall and here change the style into this new one we have just created. And see how this looks like. Okay. So the process is the same for the other objects. We can create new objects by running it from some of them can be created from curves like beams, curtain walls, or railings, and others just by an insert point and detecting walls like these openings. Let's see how to create a new object style in case of doors, but from a Grasshopper definition. Okay. So I'm gonna open Grasshopper. I will open a document that generates this object. Let's see where it is. Oh, here it is. I'm just gonna move this in another part so we can see the preview of what generates this definition. So basically, this is a Grasshopper file that generates this kind of B-fold door. We have some parameters to change the width, some parameters to change the height, the frame dimensions, okay, the aperture. So I decided which features I want to have for this object, the number of leaves, all right? If the leaf type, if they are blind leaves or glazed, the arrow size. So you can add as much detail as you want in this Grasshopper file. So the idea is that you get some parameters on one hand and some output geometry that collects the different parts of this object in geometry params. So I gave them a specific name because later on I will use these names to identify each one of these components. This is the frame. I have another one for the leaves and another for the glasses. And okay, I can save this definition now. Close Grasshopper. I'm gonna show this back to render it, which is nicer. And now I open the door styles. So you do right click here. I will create a new style, but just notice that here we've got the option to create a Grasshopper style. So I can open this wizard. Now I will select the file that I have just saved. So which is this one. Click next. So you need to define the style's name and the units of the definition. And now I need to select which one of the components, that were connected as a geometry param will perform as the door opening profile. So since I gave a proper name, I can identify them now. Okay, and this curve will be the one that tells this door to perform the opening into a wall. Here I've got the different other components. Some of them can be applied to the plan view representation. And finally, here I've got the list of all the parameters, and I can decide how I want to edit them. They can be by style. So if I have multiple instances of this object, any change by style will affect all the other instances. We can edit this by object, meaning that I can have different doors and each one have a different aperture. And also we can edit, we can put something by definition. That means that it will be hidden from VisualARQ dialogues. Okay, so it's something that we don't want to edit and we don't want to see. So in the case of aperture, I'm gonna set it as a by object, the width, the number of leaves, height, also something I want to edit by object. Okay, I click OK, and now I've got this door as a new object in my library of door styles. I can select each one of these components now, assign different attributes. For example, in the case of these glasses, I can assign some glass material. Okay. And now I can insert this, this door in here. So I'm going to look for this, for the style here. have one copy here, another one there. And now if I select one of these doors, I will be able to change the the parameters that I decided that were editable by object. For example, I can change the number of leaves here. I can also change the aperture of this door or the dimension. Okay. So with this integration, you can expand the library of VisualARQ objects through Grasshopper definitions. And at this point, once the styles are created, you don't need to know Grasshopper. So at this point, I could share this file with anyone that doesn't know Grasshopper or not even know what it is, and they could use this door, okay, as any other door that comes with VisualARQ. All right, so let's see a bit more of the documentation tools. And for example, we can create some section views or plan views in a different way as, showing, the real-time view and printing them with the hidden display mode. We can also generate a plan view. We select the level we want to display. We select maybe all this drawing and insert that into one point in the modular space. So this will be just a 2D block linked with a 3D model. Okay, any change that we do here, for example, we stretch this room by moving the control points. All right, and later on we can just come here and update this plan view, and everything will recalculate all the changes done on the 3D model. This is quite useful if you need to export that to DWG, or if you need to edit a little bit this 2D, because if you explode that, you will be able to work with the resulting 2D lines and hatches. Okay. I'm gonna delete this by now. Also, we can insert the spaces. So basically from the top viewport, I'm gonna maybe create some spaces here. So you can click inside that area. Okay. There are different styles. You can decide which information you want to show in that space, and maybe have a different one, another one here. Of course, I should give different names, okay, to these spaces. But the idea is that they are linked also with the geometry, with the geometry that are in they are around. So if I now select these two spaces, I update them, so the area will be updated with the new recalculation. Okay, and actually can name these spaces. Gonna call this room 1. This would be the room 2, and finally this would be the room 3. Okay, I can now list these spaces with a table command. I select a table style for different object types. In this case, I have already one prepared for the spaces. I select these spaces and I get here the table with that information. Okay. So just notice that, well, here we can add custom parameters to geometry. I created previously a custom parameter called floor, and then I can also fit objects with that information. So I can tell these 3 objects that they are in the floor, the ground floor. Okay. And now I can update this table, and this information will be displayed on that property field. Okay. So you can list information of any object. If you explore the table of styles, I will right-click here and select, for example, these spaces. I can see here these parameters. For example, the perimeter references the perimeter property. That custom 1 floor references this floor, and we can add here new property fields, okay, for listing any other information. If we select here the spaces, we can see here all the different object types that we can use for generating quantity takeoffs. So they are all the VisualARQ objects, but also we can list points, blocks, curves, reps, extrusions. All right, so anything can be listed in tables. And actually, if we take this volume, so this is actually a poly surface, just notice that we also have here the option to feed these objects with custom information. Okay, so that's why we can list this data later on. Or, for example, in the case of this is also a poly surface, we can tell that this is a ramp. So if we need to export that to IFC, we will select that object, go to this IFC tag, and look for the corresponding, type. In this case would be IFC ramp, to export that object accordingly. And well, you can also assign these IFC categories by layer. So if we go to VisualARQ, we've got the IFC export options dialog, and here we can tell, for example, all the objects that are in the layer slabs to be exported as IFC slabs, right? So not only, of course, VisualARQ slabs, true slabs, but geometry that we want to, Rhino extrusions, for example, that we want to export as slabs. All right, before finishing, I would like to show some examples created with Grasshopper. So, so I'm gonna open Grasshopper 1 second, and I'm gonna, in a new file, I'm gonna show a little bit how is this option to produce, to work with the VisualARQ objects inside Grasshopper. For example, if we want to create a wall from any curve like this one, we can just reference this curve. So now it's linked with this component. And here we've got the wall component that requires a path curve. Okay, so now it's linked with this curve. All right. Same if we expand a couple of points. And this wall took some default options like the head or the style. And we can add more details to with this wall options component. We'll connect that here. And now we can enter a numeric value that goes from 1 to 10, okay, for the height of the wall. Okay. And well, in the same way, we can reference some wall. For example, we can reference one of these walls. And we can obtain the information of this wall, for example, with a VisualARQ deconstruct wall. So we can obtain the path curve, and on that path curve, we can also insert new windows. All right, maybe we can generate here some windows. I'm gonna divide this curve, for example, into different points. Okay. Maybe I can have control of the number of points with this slider, okay, and insert new windows in these positions. The host will be that reference wall. The points would be the position will be these points, and I can put here some additional options, for example, to control the elevation, to control the window size. Maybe I can just call the first and last point. So with a panel, I can make this multi-line data and use the cool index to cool the first and last, items of this list of points. All right, so just keep the intermediate ones. And well, finally, I can use this VisualARQ window options component to add more details to these windows. For example, the elevation slider. Well, in the case of the elevation, I should move the original points, of course, so you can move them up. according to a vector. So we'll use this slider to connect this to the points. So move them up, and that way I can also control the elevation of the windows. But actually, from a profile component, okay, I also can control the size of these windows. Okay, maybe I can set the values to be maximum of 3, and I connect this to the width. I connect this to the height, and control parametrically all the objects that I am inserting here. So everything is controlled by this definition. So I can control the number of divisions I've got here. I control the dimensions of the windows parametrically. So you can have control. You can automate processes with VisualARQ in Grasshopper this way. And maybe I can show you another example. For example, to create this domino structure. This is actually something already created. I'm gonna just move this a little bit aside. But basically, this Grasshopper definition generates this structure, and everything is generated from using columns, using these footing that are actually columns as well, slabs, and stairs. So when I change the parameters that define this definition, I can control the number of rows in one direction, rows in the other direction, or we can control the number of levels or the levels height. So imagine that you couldn't do this parametrically. It will take ages, to do the same results. So with this Grasshopper integration, you can iterate through multiple design possibilities, and of course apply changes very quickly and automate any modeling process. All right, so I'm gonna leave it here. There are many more stuff that I could show, many other possibilities to explore, but of course maybe I will leave some time for questions if you have any. If you don't have any, well, we can just let you know that we're available, for technical support, for anything you may need, any request, and we'll be happy to help you.
OK, sorry， 我刚才声音没有打开。刚才我们进行的这个现场演示已经结束了。如果说还有其他功能，需要这个 Francis 这边去进行演示的话，可以跟我们折向联系，我们去安排。接下来的时间还有一点时间，我们可以进行一个问答环节。如果有问题的话，可以直接开语音，我们来沟通。想问一下这边是否有问题？如果没有问题的话，我们今天就先到这里结束。如果后面还有问题的话，可以随时与我们这边的销售进行联系。OK， 好，那今天我们就先到这里结束，感谢大家的参与。Okay, Francis, I think the customers don't have questions at the moment.
Okay.
So yeah, if they have questions later, they can contact us, and I will forward the questions to you. Okay.
Okay, perfect. So thank you very much, Amy. 谢谢。And we keep in touch. All right.
Okay, thanks for your time.
Bye bye.
Okay, bye.